Microscopy Nodes is an add-on for Blender that allows you to load microscopy data with a lot of versatility. So for this, I'm going to show how to install and use the new version of Microscopy Nodes, Microscopy Nodes 2, which has a new interface. So I'll first delete the objects that we have in the scene with A and X, and then we can go to Edit, Preferences, and then here in Get Extensions, we can search for Microscopy Nodes, where we can press Install, and this will install Microscopy Nodes. And that is immediately shows up here under Scene Properties as a new panel with a lot of information, but mostly what we care about is the place where we can put in a file. Which can be either a Tiff file or a Zarr file. And I'll first show it with Tiff files, and then I'll show it with a Zarr file. So let's go to a quite complicated Tiff file. I'll quickly show how this looks. This is a bit of a weird data set. This is from my lab, from Ivana Chavka. We look at meiosis in C. elegans. And so we have this marker, which is the synaptonemal complex, which holds the chromosomes together during meiosis through time. Here we're looking at the maximum Z projection in Fiji. And then we have, in the second channel, we have the spots where the crossovers are. Then in the third channel, we get the localized spots of the crossovers per chromosome. This is analyzed with SpotMax. Then we have the chromosomes, so the separate traces of the synaptonemal complex signal made with big trace. And we have the size, the analyzed size of all the spots. Once we put this in here, we can see it has immediately filled in a bunch of things with the metadata that's already in the TIFF file. And this TIFF file, and we can then also still edit this data. So for example, here, the Z pixel size is not correct, so we can still change this here. And we know that there is, we can rename all of the channels to the actual channel that it is, just for convenience, because then all the buttons later will make sense. And then we have buttons for how to load each channel. So the first one is just load as a volume, which is every pixel, every voxel is just taken as a scalar value and rendered as a light source if you have the light bulb on, or rendered as a relative density, a relative fog, if you have the light bulb off, which for fluorescence data, usually you want this to emit light, and for things like EM data, you want to absorb light usually, so then you would turn off the light bulb. But this is for normal data. Usually you want either this or the second one, which is an isosurface, which is a process where you threshold the image. At the threshold, you make it into a mesh, and you just make a surface at that threshold and then see what the data looks like then. So here we'll still just load the first two channels as volumes, but then these other two are analysis channels with integer labels. And for this, we'll actually use this different setting, which is for label masks, which loads separate values in the mask as separate mesh objects. So here we'll get, for each integer value, we'll get a separate object, and they'll also retain their value through time. So we can actually keep our masks that we made earlier, keep all the values when we throw this into Microscopy Nodes into Blender. And then for the CO size, I think this is best shown as this isosurface, and then we'll immediately also see what the isosurface looks like. So we can press load, and then it makes a few files on your computer, which are stored at this location to be able to load from your computer immediately into Blender. And this is usually temporary files, but you can put them also at a specific path or saved with the project. So then we can go to a rendered view. And here we can see everything that has been loaded. So it has made a cache that we can click away and the actual object that we're looking at with the axes loaded, the label masks, which here were for the CO sites and the synaptodemal complex traces, where the sites are so small that they can't really be seen. I have a different video of how to render these that they're actually visible, which will be linked below. The slice cube, which doesn't do anything but does allow you to slice it if you slice the data if you move it. The surfaces, which here were these ISO surfaces, which were the CO sizes. And the volumetric data, which is two colors, white and cyan for the CO sites themselves. If we now try to press load again, we would load a second copy of this data, which can be useful if you want to show different kinds of renders next to each other. However, for now, I also want to show that you can this as a reload this object, and then we can change the settings. So for example, we can turn off some of the channels and only load the data, and we can then also maybe just load the data as surfaces. So then you can see that we reloaded the data with different settings. And now in the surfaces, we would need to set the threshold slightly different. But you can see that there's the data through time as it was. So this is how this reloading works. This can also make sense for if you have, for example, temporary files that got deleted, you can still reload them like this. Here we have essentially everything that we can do with TIFF files, and this is, I think, already quite powerful. But with OME-Zarr, this format gives a few extra features, which I'll show right now as well. So we'll first delete everything in the file. So here we have the URL of an example Zarr that I have online, but you can also use Zarrs from different online databanks. This is an expansion microscopy dataset made by Granita Lokai. And you can see that because it is an OME-Zarr, we have a few extra things. One is that the channel names have been filled in from the file, but also that we can select which size to load the data at, because there's multiple sizes of the Zarr stored with the data, and that it's directly loaded from a URL from online. So we can now load this, and we can see in the smallest size that our resolution isn't great, but we can already make we could make all of our camera movements, all of our animation in this smaller version, and then later reload the object at a different scale. So for example, with one scale higher, you can see that, oh yeah, the resolution is already quite high. So here we could make our scene with a small version and then eventually scale all the way back up to our 48 gigabytes of data in the full resolution of this expansion microscopy dataset. And even if you don't have locally this amount of RAM to handle 48 gigabytes of data, you could also, for example, exchange the data from the command line and render from the command line as well. So you never have to actually open it with the giant data as well. So there's a lot of things that you can now do with microscopy nodes, trying to edit all of these different objects, all the things, the thresholds, which channels are included, camera animation, slicing different channels with different boxes. However, this I'll leave for other tutorials. There's a few tutorials I've already made showing a pipeline both for the TIFF dataset that I already showed and one for an EM dataset by Microscopy. And I hope that this was helpful in using the new channel interface for microscopy nodes.